A very good morning, everybody, and welcome to yet another webinar brought to you by SAIOSH, the South African Institute of Occupational Safety and Health, which is a SAQA recognized professional body for health and safety practitioners in South Africa. SAIOSH got 3 professional designations that are registered on the NQF, namely Technical Occupational Health and Safety Officer, a Graduate Occupational Health and Safety Practitioner, and Chartered Occupational Health and Safety Professionals. For those of you that are visitors today and not a member yet of SAIOSH, I urge you that if you are operating in the field of occupational health and safety, to consider to be professionally registered with a SAQA professional designation. My name is Niels Nokia. I'm the CEO of SAIOSH, and we are excited this morning to bring to you yet another free-to-attend technical and informative webinar, mainly aimed, obviously, for our members, for educational purposes. And we are pleased to have this morning Protekta with us that's going to deliver this very interesting topic on anchor points on your site and what to look out for and all the technical aspects around it. Just a quick couple of house rules and information. This webinar is CPD verified by SAIOSH with 1 CPD point. So members can, after this webinar, claim 1 CPD point on their profile. Also, just note that this webinar is recorded and live streamed this morning. We had a tremendous amount of registrations. In fact, we have had over 1,000 members that have registered for this webinar this morning, which shows the interest and the need for this information this morning on anchor points to be dispensed to the health and safety fraternity. So this webinar is recorded. It's live streamed on our YouTube channel. And obviously, if you miss it or if you want to go back and view some aspects or even play it back at your workplace, it will be living on our YouTube channel. And for our members, the presentation will be made available and sent directly to you as a member so that you can have that as well. And also, all attendees will receive, tomorrow, you will receive an email proof of your attendance for whatever reason you want to use it, perhaps to try and claim CPD from other professional organizations, but your SAIOSH CPD point is claimable directly on your profile. Right. Just regarding the chat and the Q&A, please use the chat as usual to meet and greet and send messages of thanks or anything if you perhaps got possible, if you got any queries with sound or something, and Gareth, which is in the back end, will try and assist you with that. But stick to meet and greet for the chat tab, and the Q&A tab is only for questions related to this morning's topic. Can I also please plead and ask not to start posting topics straight away? It's going to be a full hour presentation, and there's lots of information this morning that's going to be get from our presenter. So please, if I can ask that you don't start straight away with questions. Please give some time for the presenter to go through the presentation, and I'm sure that your question will be answered in a short while. Right. As I indicated this morning, if I can maybe ask the General Manager of Protekta Safety Gear, which is Dylan Sutherland, if you can maybe put your camera on. Dylan, welcome to this webinar this morning. Thank you for taking the time out and to come and share this knowledge that you have on this very critical topic. Just a quick overview. Protekta Safety Gear is a South African-based Level 2 BE and privately held company established in 2005 that specializes in the supply of personal protective equipment, apparel, and comprehensive safety solutions. Protekta offers a wide range of fit-for-purpose safety products and services with specialized divisions in fall protection, which is we're obviously going to hear from this morning, and confined space equipment, including training and solutions. Their services include safety gear, specialized services like fall protection and confined services, including equipment inspections, site assessments, and repair and recertification of fall arrest gear. The brands that they cover, they are officially distributor and Service Center for 3M fall protection, and they partner with the likes of UVIX in South Africa, and more importantly, Protekta is a corporate member of SAIOSH. Their target industries that they service is construction, mining, manufacturing, and general workplace safety. Ladies and gentlemen, please welcome Dylan Sutherland, the General Manager of Protekta. Dylan, thank you. Over to you, and we're looking forward to a great presentation. Thanks.
Thanks for the kind words, Niels. And yeah, I hope we can add value. As Niels has alluded to, our business is obviously a safety business, but our primary goal is to increase knowledge and make sure that we're sharing valuable knowledge that can keep people that are ultimately at risk safe. Just need to open up. So yeah, I'm going to try and be as clear as possible with this webinar. It's quite a technical conversation. As Niels alluded to, it is a full hour, but to understand the full topic, I think we need way more than an hour, but it's a good starting point. So if there are questions, if we can deal with those later, that would be really great. Before we jump into the conversation about the anchor points, I think it's critical that every single talk I've done this year, and it's going to be like that for the rest of the year, we need to just quickly take a look at a stat that I believe is highly overlooked. And ultimately, we're exposing people to become statistics. So what we looked at was FEM. FEM, we've used their stats from 2015, and we looked at their stats at 2025, 10 years on, specifically to fall protection. So falls onto different levels and falls onto same levels. And we need to look at this from a slightly different standpoint, because we look at the same things all the time. And these stats, unfortunately, are generally the breadwinners, which means that it's got a bigger knock-on effect should they get injured in these situations. So the first thing we're always looking at is how many accidents happened. And if we need to look at that, I mean, 2015, there was 1,200 odd. That dropped down to 909, which is phenomenal. That's less 25%. That's a really good direction. We're doing something right. The second one we're always looking at is the lost days. So if we look at lost days, we see 10,300 down to 8,000. It's again dropped 21%, which is really, it's good going. The next critical one is obviously fatalities, where we've gone from 10 to 7. So we've dropped by 30%. However, there is one that, because we talk about these so much, I think that's kind of directed the direction it's going in, where it's gotten far better. What we don't look at too often is the permanent disability component. Now, the permanent disability, as I mentioned earlier, that's the breadwinner. Generally, it's the person that's there to provide for the family. And permanent disability means that that person probably can no longer, well, not probably, can no longer perform their function. And that means they will not be paid the salary that they would perform that function for. And further to that, according to FEM, about 97% of those are not actually insured. Now, if we take a look at that from 2015 to 25, it's gone from 123 humans to 201 humans. That means it's 63% increase. That means 78 additional people and 78 additional families were affected, where the breadwinner, who was there to provide for that family, became a dependent. And I think these kind of webinars, these kind of sessions are really valuable, because we're sitting with the right people. We're sitting with the people that can influence that. And for us to be aware of it is step one. The next step is, what do we do about it? So over the next couple of months, we're doing 6 webinars with SAIOSH, which I'm quite excited about. What we'll be looking at doing is, yes, we're a full safety company, but we're going to try to tackle the critical topics. So the first critical topic we identified was obviously anchor points. And this is what we're going to look at today. So we've covered the overlooked stat. Into the anchor points, what we'll be looking at is why the anchor point selection matters. So what's the end result if I get it wrong? Before we actually select our anchor, we also need to understand what are we looking at there. So the second point we'll go to there is what are we considering before we even select our anchor? We'll then move on to what the standard proves, but more importantly, what it does not prove. And I think that will be really valuable for people that are responsible for the safety on sites. We'll then go to the installation surfaces and structures. Obviously, there's different structures and buildings, and we connect anchor points into various different structures. We'll cover those. We'll then get on to the actual location of the anchor and the orientation of that anchor and what role that plays in the actual fall. Then we'll discuss two principles which are really important for us to consider, which is fall clearance and swing falls. And then finally, we'll get into the final considerations. As I mentioned, this is quite a complicated topic, and to think we can get through the whole thing in an hour is not realistic. But what I am hoping is that the points that are mentioned today, insights, really good discussions, prompt people to ask good questions, and make sure that we're actually really trying to protect the person, not just tick a box and put something there that we hope works in the event of a fall. So let's get into it. So the first point we want to talk about is why the anchor point selection matters. So over the last month, I've taken a couple pictures on sites where it's been quite scary visual realization that we think we keep people safe, but ultimately it's not necessarily, we don't know enough about what it should look like. And the problem is these two images I'm going to share with you of site visits were people that genuinely cared about safety and were bamboozled to think they had the right stuff, but ultimately anybody that connected to that was about to become one of those breadwinner statistics that we spoke about. So the first one is this image here. It's a lifeline. It ran about 20 meters towards the green direction. And I'm hoping that right now everybody's more on the side of that looks fine. And that by the end of the session, there's a drastically different viewpoint on that. Because this incited the work at heights space quite a bit when I shared it, and rightfully so. But to somebody that trusts their installer, this was something that was perfect. This was something that would have kept somebody safe should they have fallen. The second one was on a roof. Really contentious subject right now. Same story. The people that are installing it are still thinking it's fine. It serves its purpose. But ultimately, this is creating a real life-threatening risk. And the frustrating part for me is the person that's going to be on the receiving end of that is the breadwinner who had no part in deciding it. He was just told to connect to it. So I think that's why this conversation is really important. So I hope we achieve that by the end of this session. And if we don't, please feel free to reach out if there's any concerns, questions. I mean, that's what we're here for, to support. Based on those two pictures, there's a principle in fall protection called the ABCs of working at heights. Now, this principle is specifically there to make sure that should somebody be exposed to a fall, if they have their ABCs correct, they should not hit the ground. So in the beginning, it saves them. It makes sure that they don't hit the ground. There's a next step to that, which is we need to then rescue the person, but obviously that's for a different topic that we'll discuss in further webinars. But today we're going to focus on that ABCs, and what we need to be clear on is the weakest points of that system will break. If that weakest point is the anchor point, if it's the harness, if it's the connector, the forces, they don't really care. They're going to go to the weakest component and they will break that component. And if one of these components break, the person will hit the ground. And then the system is, it's basically a waste of time. So that's what we're going to cover on the anchor points today. It's just one element of it, but it's a very important element that needs to be discussed better. So before we even get to setting our anchor points or selecting what we need as an anchor point, we need to approach safety practically. Just like we would with our normal hierarchy of controls, we have a hierarchy of controls for fall protection. Step one is, can we eliminate the risk? Meaning, can we stop that person from even needing to access that height? If we can do it, like we can see in this example, if this person was tasked to go paint a structure, and they would normally do it with a scaffold, by replacing that scaffold with an extension pole, they would stay on the ground and they would be safe. That is prize one. We don't want people to leave the ground. If we can eliminate the risk of falling, we eliminate everything else linked to it. Now, it's obviously not always practical, but it needs to be part of the consideration. The second part is, can we engineer the risk away? Meaning, can we create a structure or create some sort of structural restraint? It could be a wall, it could be a guardrail, it could be multiple different ways of removing the risk of falling. If we can do that, and if we can get to that height, so we can't climb a cat ladder and then get into a scaffold and think that we've engineered the problem away because the scaffolding has barriers. There's still a risk getting up there. But if we can legitimately remove that risk, so we create a staircase and the staircase goes onto a platform and it's got proper guardrails and it eliminates the risk of falling. That's prize number two, because both of those instances mean we don't even need to start considering fall protection equipment. And that's ideal, because if somebody doesn't have a chance to fall, they don't have a chance for their systems to fail, the ABCs, and they don't have a chance or a requirement to be rescued and ultimately potentially suffer disabilitating injuries or worse. Again, practicality is what we need to consider. So quite often we can't always engineer the problem away. We then get onto a fall restraint setup. Fall restraint is where PPE starts getting introduced from a fall protection point. That means we stop the person from being able to access a fall. So if I were on a slab of concrete and I had an anchor point which was 5 meters behind me, and I gave the person a 4-meter piece of rope, and they couldn't actually be exposed to the fall over the edge, and they could still do their job, phenomenal. We want that because we want to eliminate the risk of falling as far as possible. The last step basically is we need to then look at fall arrest. Here we need to give the person a solution that's going to actually stop them from hitting the ground. We've established that eliminating engineering or creating a fall restraint system isn't practical, maybe for the job. We now need to give them an ability to, yes, they might experience a free fall, but ultimately they're not going to hit the ground or whatever's beneath them. And that's always our last go-to, with then administrative controls being considered from a training, from a SOPs for protection plans. This would quite often hit the first or the third and the fourth topic. But this is just a consideration before we even start talking about anchors. Now, what we need to be considering is it practical to remove the need from leaving the ground? So is it practical that this person can perform their function from the ground and not actually have to get to heights? In most cases, no. We need to consider, how often will this task be carried out? So is it a job that's being done once a year? Is it a job that's being done once a week? Those are two very different risk factors that are going to be at play. And that should be kind of aligning and driving our thought process as to how do we keep the person that's actually doing that task safe. We then need to think about how long does the task take. There's 2 points on that. One is we know that a rush job is generally where safety gets ignored, and we're just quickly going to do this. And that's where a lot of incidents happen. The other thing, though, is from a practical component, if somebody is tasked to do a job that takes them 5 minutes, and we are trying to make sure we drive safety and not enforce from a policing point of view, when you give that person a system that they need to take 20 minutes to set up to do their job of 5 minutes, we need to understand that that person's probably going to bypass safety the moment they're not being watched. So we need to make it practical, and we need to understand the full scope of what's being done. And the last consideration, which I believe is the most important, when we talk about the person using the equipment, is that person the breadwinner? Are they a safety specialist? Are they a work at height specialist? Or are they, in fact, a technical specialist, being maybe a boilermaker, an electrician, a plumber, that just happens to have to do a job at heights, which isn't normal? And it's quite an important consideration, because when we start creating complicated and complex systems, I don't really think it's fair to expect somebody who doesn't do fall protection consistently to be able to build complicated systems, yet they're the ones that rely on it to keep them safe. So we need to be very thoughtful, especially since it's the people that own safety. These are the considerations we need to take before we even selecting an anchor point. From there, we do need to understand the standard. I don't want to spend too much time on this, because we can talk about this probably for the rest of the day. It's very complicated, and I'm going to try and make this as simple as possible so that it's relatable and valuable to the audience, and you guys can then use that knowledge, hopefully moving forward. So when we talk about the standard, let's quickly discuss an overview of our current standard. So in South Africa, we know we adopt European standards generally, and the standard that we've adopted is the EN 795, which has been taken on as SANS 50795, 1996. Now, we need to be very considerate about this, because when we look at global, currently what's being applied in the in the global market that follows the EN standard is the EN 795, same standard, but the 2012 revision. And that means we are a good 16 years behind. We haven't updated our revision, and there were real reasons as to why, which are linked to this next piece, which is the technical standard TS 16415. What happened was, when the EN standard was updated in 2012, it went from multi-person use to a single-person use anchor point. And the reason South Africa couldn't adopt that was, at that stage, we understood we could not adopt a technical standard. And this technical standard 16415 says multiple use. How do we test a EN 795 anchor point for multiple users? So it wasn't because of South Africa didn't want to, it's just that was the state of play. This is currently a very hot topic, and it's something that's getting moved forward. However, there's also a reality that in Europe, they're already looking at the 2025 revision of EN 795. So there's a lot going on, but what we need to understand is, if we are looking at anchor points, we should be referring currently to this. And to throw another spanner in the works, there's just been an EN 17235 that has been accepted globally from a European standpoint. And ultimately, that is going to replace a big chunk of the EN 795, which we'll just quickly touch on. So without getting into the technical details there, when we talk about the EN 795, we talk about different types of anchor points. So what we're going to quickly go through is the different types, because these would be the considerations you need to think about when you're selecting an anchor point for your site. Now, type A is a fixed anchor point. That means it's going to be installed permanently, and it's going to not allow somebody movement or ability to travel. So when I put this in the ground or this in the ground and I try and move, it will not move with me. It will restrict me from being able to move away from it. So if I've got a 2-meter lanyard, I can't move 2 meters, more than 2 meters from this. Now, we'll get into the different surfaces. What we must be aware of is brick and roof are currently a really dangerous space to be discussing, and we'll get into a bit of that just now. But this is what you would consider a type A anchor point. We then move to the type B, which is a temporary or a mobile anchor. This is where you would be doing a job and you've got a piece of I-beam and you can connect an anchor point, whether it's this fixed beam anchor or a sling, and you can connect it and create an anchorage point, which would stop you from hitting the ground should you be experiencing a fall. A tripod is also actually certified as such. And you also get different types of anchors where it's more of a temporary. So this acts like a raw bolt almost. You pop it in a hole, you drill a hole, you pop it in, you release it, you then have a safe anchor point. But obviously these need to be as per the OEM's instruction of use, and that's critical. But we'll get into that a bit later. So these are your type B. Generally, they're going to be something that I can use here. I can move to another area, use it again, and it will move around with me, and I can probably use it in multiple different areas. However, I do need a structure or something to connect it to. We then look at type C. So on type C, we start talking about our horizontal flexible systems. That could be either a temporary lifeline or a fixed lifeline. Now, what this gives us is, this gives us ability to move. So again, if we use the situation where I've got a 2-meter lanyard, if I'm connected to a type A, I can only really move 2 meters away from that anchor point. If I'm connected to a type B, same story, most of the time. Type C, however, gives you a line, and that line will allow you to travel up and down, still with your 2-meter movement, or whatever connector you're using. And this allows for a more mobile person. So if I'm doing a task that requires me there and then later there, we consider a more flexible horizontal system. So that's your type Cs. We then get to type D, which is the same concept, meaning it will travel. So I will be able to move along a length. There's a few different considerations with this, though. With cable or with webbing, if you have to run a line, say 10 meters, and pull in the middle, you'll create quite a bit of movement. You'll create quite a bit of sag and deflection. So a rail system, a type D, horizontal rigid system, that ensures that there is no sag. So that's the one benefit of it. The second is that aesthetically, it's also better looking than having cables running through areas. However, obviously that's very specific because that comes with its own price. What must be noted, and what we see often on sites, is people turn this upside down and they have it overhead. Now, if it's certified to your EN 795 type D, and it's certified as such that it can do that, there's no problem. The problem, though, is quite often on site, we just see a Hillel-Dam kind of glass holding rail, which is designed for sliding doors, not for people. And it's critical that we do understand what the standard is that needs to be met for this to be safe for a human to use it. And then the last one that we talk about is type E. Type E is a deadweight anchor. I can't say that it gets used too often because it's not practical. You can move it around, but once it's moved, it needs to be loaded with weight plates. You then need to create an anchor point. And once again, if you can imagine this person's trying to inspect a gutter, he's probably not going to take an hour setting the system up to go do a job that takes 5 minutes. So the practicality of it does quite often let this down, and we don't see too much of the Type E's, but they are there and there is a certification for them. So this paints the picture of anchor points and the certification. Specifically, it's excluding vertical. So vertical is its own discussion. That's a 353 standard. We're just talking right now 795 and the technical standard, which obviously supports it for multiple users. Without overcomplicating, right now, this is what is being applied, and it applies to all of this. This EN 795 standard, though, was not intentioned for permanent. When it was developed, the intention was more for temporary and mobile anchors. So in the future, how this would look is EN 795 plus the technical standard will cover these specific elements. And when the new standard is fully incorporated, it will take over more of the permanent functions, because that's more what it's been designed for, making sure that the certification is appropriate to permanent installations, where right now that's a huge gap. So we've just quickly gone through the standard itself and how it looks from a very general standpoint. What we want to understand is quickly, what does the actual standard prove? So if we talk about the product and the performance of the product, it proves that each of those products will be designed to safely arrest X amount of users. All of them are different. From 1 to 4, you'll have to obviously understand the product and read the manual to understand how many users. But that standard, or the certification, that's one of the components it touches. Another one is that it will safely arrest the fall without breaking. We need to know that. We need to be 100% sure that if I fall on this anchor point, it's not just going to break. It's not just going to rip out. The other thing the standard will prove is it will safely arrest a fall if it is used correctly. Now, that's quite a nuanced area, because correctly could be the user using it correctly. But what you'll see just now is it could also be the actual installation. But ultimately, the standard tests that. It says if you use this correctly, if you use it as it's intended and as it's been built, it will keep you safe. It doesn't say what will happen if you don't use it. Well, sometimes it does, but it can't allow for everything. And then we also look at it will safely arrest per unit or per system. Now that means when we talk about a lifeline, for instance, a lifeline doesn't get certified as a component. So the end plate is a certified component, the cable is a lifeline, or anything that's horizontal in that kind of manner, gets certified as a system. Even if you think about a temporary lifeline, you can't add other components to a temporary lifeline and then expect it to work the same, because it hasn't been certified as a system. So a single anchor point, it will get certified as a unit. A horizontal lifeline will get certified as a system. So it needs to have all of those components correctly fixed, correctly installed, correctly as per the OEM, and then it will save your life. And that's what the standard proves. And the final thing that the standard will prove is that you can put an EN standard on it, as well as a CE certification, saying that because this is category 3 safety, or PPE, it's been tested and it's been quality assured to make sure that it will work in the event of a fall, as long as it adheres to this. Which is why it's quite important for us to understand also what the standard does not prove, because adhering to this is just the first step. So how you can look at it, adhering to this, is when a product comes with a certification that says, I am EN 795 certified. I am EN 795 compliant. Well, we shouldn't compliant, but certified. So what the next part is more from our side. So has the person who has used the product used it as intended? Meaning, if I use a sling on a structure that is sharp, am I using it correctly? Or a structure that has heavy rust, am I using it correctly? No, I haven't. Probably I might not have had the right training. I might not have the product knowledge. I might not have done a structural integrity test. If something happens there, it's been certified. But has it been used safely, arrest or fall, if used correctly? No. If we've used this incorrectly, unfortunately, it's not going to work. And the standard can't account for that. The next thing that the standard can't account for is, has the installation been installed and tested per the OEM requirements prior to use? So in this instance, the product carrying the EN 795 will have been tested and should have been tested and certified. So EN 795 plus the CE compliance according to the standard by the OEM. When they sell that product, it comes with that. Now, the next step is, has it been installed and has it been tested as the OEM requires? They will certify an installer. They need to give them a go-ahead and give them a certification saying, we recognize you as a competent installer because you have attended X training or you have X subject knowledge or whatever their criteria is. It's obviously down to the OEM, but ultimately that sits with the installer. And more important for you as the person who owns safety is the proof that it has been pull tested, the proof that it has been tested in accordance to the OEM requirements. Because if something does happen and you don't have that proof, maybe just a side note, the proof isn't, I'm Dylan, so I'm giving you a certificate. You can trust me, I inspected it. That's not the proof. Me as an installer, I have to test it, meaning I have to pull certain components of that system for a certain kilonewton rating for a certain amount of time. And you should be holding me accountable to that. You should be telling me, look, where's the proof? That's a certificate, thank you. Where's the actual proof that you've pull tested that for the period, for the kilonewtons? Because that's going to save you should that system not work. And another side note, being an LMI doesn't make somebody competent on this point. Lifting and working at heights, fall arrest, very different conversations. Lifting is a static load. Fall protection is a dynamic load. There's no shock absorbers. There's no impact, or there's impact indicators, but there's no shock absorbers in lifting. There's a very specific reason to that, because if a lifting load drops, there's big trouble. So that is another critical consideration. So in this instance, for example, like I mentioned, there's actually a plate that says this has been installed by X company. There was a physical certificate, but unfortunately the person that owned that safety on that site didn't know what to ask for or look for. And they ended up getting tricked to believing 100% that this product was keeping their people safe when they connected to it. Same as this. When the installer installs and they can't give you the OEM EN795 standard, you wouldn't be able to get that on this. Plus then the OEM recognizing you as a preferred or an installer, you should be asking the questions. Then the next thing that the standard doesn't prove is the system safe after whatever period? Meaning, is in a year's time, is it still safe for use? And there we need to make sure that these products are undergoing their required inspections. For you guys, that would mean that there needs to be periodic inspections. If there's been a change to the site, or if there has been an incident linked to that product, it needs to, because most fall protection equipment needs to be disposed of once it's been in a fall. So it needs to be retested and certified to make sure that it's actually still in good use. Now, that again, you'll get periodic inspections and the pull test. Once again, you don't want a certificate, you want proof. Even if it's a video of some guy pulling that thing for 3 minutes, proving that it kept the kilonewtons, you should be demanding that. And then we get onto the quality conditions of the structure. So this is really, really important, that we can't consider every single structure the same. An RBR sheet, R-beam in Joburg exposed to the elements versus an R-beam in Cape Town exposed to the elements are two different situations. So from a perspective of how do we make sure it's safe to connect, there should be a visual inspection. If it's at all concerning, and if you've got the right people doing the installations, they should demand a structural integrity report to make sure that if I put the system up for you and somebody falls, yes, the lifeline might stay in place, but if the structure falls over it, it's not going to help anyone either. That should be part of the consideration. And once again, we should be pulling it. So if it's into concrete, for instance, you can't really see if concrete's degraded always visually. A pull test will tell you that. And the proof for you guys is, I want to see it being able to withstand that force for X amount of time. That will make me comfortable to let my people connect to it. And then the last one is, has the system been used with substitute components? So like I mentioned, the fourth point at the top here, it will safely arrest per unit or system. In a lifeline system, the moment you substitute a component, you've removed that certification because it was certified as a system, as a complete, as a whole. You can't pick and choose what, or nobody can pick and choose what to replace it with. If the OEM says it's fine and it's certified, that's a different conversation because they're the ones that carry the certification. But it is something that should be questioned. So permanent lifelines in particular are certified as a complete unit, not as a component. So once again, if I take this example, even if I take this turnbuckle out and I create a proper connection to this endpoint and I put a shock absorber in here, substituting something that works in fall arrest will not make this compliant. Likewise for the roof. If I put a shock absorber over here, the likelihood is the solar clips are probably going to pop off and we can have a much bigger problem. The shock absorber might not even be deployed, or if it gets deployed, it might just rip the whole thing off. So to show that in practicality, there's a little bit of a video here. So the weight that gets dropped here is obviously simulating two people dropping on a single anchor point, which is what it's designed for. And this is the result if you have a certified anchor, because like you can see, that anchor point is not breaking. That anchor point is strong. However, it's not designed to be installed as it is being used in this situation. Then what we've got is, as the video goes on a bit, you'll notice that they're still working in the exact same roof. So the holes are over there. And they do the same test with a product which is both EN 795 plus certified for that use. And under the same arrest forces, under the same conditions, this is designed to remove the risk or remove the forces from the base plate, which then removes the risk of this ripping off. And once again, if you just look at these two items as EN 795, both of them probably comply. Both of them probably meet the minimum requirements or the requirements of that EN 795 type 1 in this instance. However, one is fit for purpose, meaning it's designed to actually be used on this kind of situation, where the other is more designed for probably into a different kind of structure, a structure that's solid, the structure that's actually going to withstand the forces that get transferred. So I think when we talk about what the standard proves and does not prove, we need to take away that the question isn't how strong the anchor point is. The question is, what is it being anchored into? Because that makes a big difference. And then once it's installed there, what is it being required to do? Not all anchor points. These were both type A, and we could see a very different result from them. Okay, we're then getting into the installation surface and structures. So we want to quickly cover the different kinds of surfaces and considerations linked to those surfaces. So when we talk about concrete, we'll talk about certain requirements. So things like the thickness of the slab of concrete. If you're trying to install this stud and there's the slab of concrete finishes halfway, you're not creating strong enough anchorage or certainty that in the event of a fall, this will withstand. So the thickness of the concrete slab is very important. The density of the concrete is also important. So we need to make sure that it's been poured in a manner that is actually going to withstand a fall should it be exposed. And then the other consideration is, how do we connect? So this is a mechanical fixing, and then you get a chemical fixing where you would put chemical mortar type of system or fixing into it. Now, for that, so especially on the quality, because we can't tell the quality of that concrete, we need to do the proof, which is the pull test. So in this instance, the anchor point, like we spoke just now, that would carry the EN 795 standard. The stud, however, very often doesn't have anything to do with the anchor. So how do we make sure that that is also safe? And that's what the standard does not prove again. So when the stud gets installed, it needs to be pull tested. It needs proof that I have tested it according to the OEM's requirements for X amount of kilonewtons, for X amount of minutes, and a piece of paper does not suffice. You should be asking for the proof. I want a video of this thing keeping, because to give you an idea, if this concrete is a bit damaged, what could happen is we could put a pull test on here and it can pull and it will maintain 6 kilonewtons. And then it might start dipping. And if that happens, that means this is probably, there's going to be a dysfunction when there's a fall arrest situation. And it's imperative that the safety person, the person that owns safety, that is responsible for that, understands what that check looks like. The other thing we can do is we can also use temporary anchor points into concrete. But this, I need to emphasize, you need to make sure that you are referring to the OEM's instructions for use, because that will talk about the competency of the person. That will talk about the checks to make sure that it's actually going to work as intended. But these would be two considerations you could use when working with concrete. We then move to steel. Steel's a lot better. Steel's a solid structure that generally, if it's in a decent condition, isn't going anywhere. Obviously, we can't just take that at face value all the time, but we need to do our inspections. We need to do a visual inspection. We need to make sure that we're not using an angle iron, which is 2 mil thick for an anchor point, because we do not have certainty that it will withstand. So a general way to understand or contemplate whether or not this would work, if you can imagine a 1.5 ton bakkie being lifted by a crane and connected to that structure and just let go, not dropped, just let it hang. If that structure can hold that 1.5 ton bakkie, you're probably good. If it can't, so like a PVC piping or your internet cabling tracks, if you believe that that bakkie will pull that cable track down, you can believe that it's going to pull the whole structure down in the event of a fall. But here we would consider permanent anchors again. So you can put it in. This time you wouldn't really do a pull test because the pull wouldn't do much, but you would do a torque test. making sure that it has been properly tightened. The other one is if you weld it, you can weld it on. You would then need welded certification or inspection. The other thing you can do is there are some products that allow you to clamp around the structure. Once again, if it's clamped though, you need to refer to the OEM, or you need to make sure that whoever's installing it for you is adhering to the OEM's requirements. The other thing we can do, and quite often do with steel, because it's quite a robust structure, we use it more for temporary. So we can put temporary anchor points and temporary lifelines on it. It's a lot sturdier, obviously, and you've got a lot more certainty. Once again, we need to make sure the person is competent that's actually using and installing it. And then we need to also make sure that the instructions for use are followed. That might include a visual inspection, making sure this structure is still in a good condition, making sure it fits properly. Things like that would be part of the OEM's instruction for use. Now the big baddie. So brick walls, we should never do this. The problem with a brick wall is, and here's a really cool example. I mean, they've put a plate on it. Does that mean it's safe for use? We don't know. What happens with a brick wall is, if you think about bricks, they're quite porous. Put it in water and pick it up, it's going to be leaking for quite some time. It's not a solid structure. The other thing about bricks is bricks have holes. They've got 2 or 3 holes in it. Once again, it's not a solid structure that's going to arrest the fall. The third point is the grouting, or the adhesive that's getting used to stick these bricks together, basically. What strength does it carry? There's no certification for fall arrest in that, I can promise you. It's just designed to stick bricks to bricks. And then we've got, which we'll touch on a bit later, but if this pulls out of the screen, so towards us, this brick wall, if this brick is strong, it will look for the weakest component. And that might be the mortar, it might be the bricks surrounding it. The weakest component will give in. And if it hasn't arrested the fall and it finds the weakest component, you're also going to have that brick wall falling on you. So if there is permanence, which again, we should really not be considering, maybe for restraint at most, but still there's risk to that. Using it with a fixing component being chemical, but along with that, you need to also spread the load. So quite often there's a plate that spreads the load behind the group of bricks. And further to that is there needs to be a structural engineer actually signing it off, and signing it off in the direction that the forces will happen. It doesn't help we sign this wall off to hold an up and down force. This is going to be a pulling force, and it needs to be able to withstand that. Once again, rather don't do it. Let's find alternatives. Another contentious one right now, especially in South Africa, so the roof sheeting side of things. Connecting to roof sheeting is quite tricky. We've got 2 main styles of roof sheeting, so being RBR sheets or RBR type sheeting and clip lock type sheeting. So the problem we have here is the thickness of this roof sheeting is quite often really thin. It can go down to 0.5 millimeters, which is really thin. So that creates one problem. That's why when we looked at that video, that fixing point so easily ripped the sheeting off. The second thing is roof condition. Is the roof in a decent condition? Is it breaking? Is there rust? Have we painted over the rust? We need to be very serious about the roof condition itself, because if the roof's not in a good condition, you can put the best fall arrest system in there, it's just going to pull out. The other side is polycarbonate sheeting, so the see-through light sheeting. That, guys, in fall protection, most incidents are happening off of roofs, and of those, I would bet 90 to 95% are happening through polycarb sheeting. It's an extremely dangerous space to play in, because that sheeting cannot withstand a person standing on it. It's not designed for that. It's only designed to allow light through into the warehouse or whatever it's guarding. So we need to be aware of that, and we might want to do a couple checks, meaning maybe let's go on Google Earth and check what the building looked like a year ago or 2 years ago, and make sure that we haven't painted over the polycarb, or go inside the building and try and look out and see if you can see polycarb which might have been painted over. Because very often that happens, and it's not quite a risk, it's a massive risk. So when it comes to installing on these, with the RBR sheet, how RBR works is it's actually it's fixed into the beam structure. So that means if I install an anchor point and I attach it to the beam structure, it's probably not going to be too much of a problem. However, when we get to a clip lock style or profile, that gets inserted into a bracket and it's got concealed fixing. So what that means is these lengths can run 100 meters, and it's not necessarily tied down to the beam or to the structure itself. What happens there is if you try and install an anchor point that goes into the structural beam, you're actually going to end up damaging your clip lock sheeting, because when the connecting device into the structure clamps it down, it prohibits any movement. And those long lengths of sheet, when it gets hot and when it gets cold, they expand and contract. And when that happens, if you've now forced that it can't move, it will move. However, it's going to tear wherever you forced the inability to move, the pushing down. So it is really critical that we think about these, because roofs are massive investments. You don't want to be breaking the roof because you've bypassed something from a safety point, or unknowingly connected something to a product that you believe will work. There's other elements to this. I mean, there's some solar fixing clamps that are being used on the clip lock sheeting. And I mean, if the manufacturer says it's certified and you've got 100% confidence in that, then you need to trust that. But we need to consider what those solar panel clips were designed for. We also have people giving a solvent, so a glue that glues these kinds of panels onto this sheeting so that they don't tie into the structure. The reality is, this is your hardest working area on your site. The roof is exposed to sun, hail, rain constantly. This is where stuff's going to get damaged first. That solvent might work today, but probably in a couple months' time, and we've seen it, tested in a couple months' time, it's not going to be as it was when you first set it up. These are important facts that the person that owns safety needs to understand. One more on that is, quite often what we see is somebody will go and install an anchor point and then install another anchor point 10 meters down the line so that we can save costs. Now, if we think about that practically, that means the person that's going to work on the roof needs to get to the first anchor point and connect. They then need to pull a piece of rope, potentially 100 meters long, depending on how far they need to go, and every 10 meters connect to it. If that person experiences a fall and they are 9 meters away from that anchor point, they are going to fall 9 meters toward the ground. They're going to generate force during that 9-meter fall, and quite probably they're going to rip the whole system off the sheet. So what I'm trying to say is the cable's the cheapest component. Rather, if you're going to put in a lifeline, just put the cable. You give that person that's getting on the roof ability to connect the moment they get on, stay connected their whole job, get back to the cat ladder, and then disconnect. Keep them safe by making sure they don't have to disconnect. So just a quick takeaway about that is, we do not only ask whether the anchor is certified, we ask whether the surface and the installation of the suit, whether the surface and the installation are suitable for the expected load, for the fall that it needs to arrest. So even again, if this anchor point is EN 795, if I put it onto one of these roof sheetings and I drop a weight on it, we can rest assured it's probably pulling out. And that's then going to be the A in our ABCs that pulls out and leaves that person striking the ground. Okay, final couple concepts we've got. So anchor location and orientation. We all understand most of us will understand the fundamentals of 4-factor 0, 1, and 2. Just basically, 4-factor 0 is considering I'm connecting above my head. 4-factor 1 is from my head, basically down to my hips. 4-factor 2 is from or down to my knees. 4-factor 2 is from my knees down. Now, to understand how critical of a important consideration this is, I've just applied the same logic. So let's say this person is 100 kilograms. Let's say that they've got a lanyard without a shock absorber, just to figure out what the forces might look like if they did fall. And we've got different falling distances because of obviously the orientation and where they've connected the anchor points to. So in the first one, this person might experience, because if they connected at their head level, they might experience a 1 meter fall. If they're 100 kilograms, they'll create basically 10.7 kilonewtons of force, which equates to about 1,100 kilograms of force. Meaning we went from weighing 100 kilograms to just before my shock absorber deploys, about 1,100 kilograms. To put that in perspective, anchor points are generally rated at 15 kilonewtons, up to 19. Some of them from America are 22. However, the human body can safely withstand about 600 kilograms of force, 6 kilonewtons. Once I exceed that, I start exposing my body to internal damage, which could be life-threatening, which very well might be life-threatening. So this is an instance without a shock absorber, so worst case scenario. When we look at 4-factor 1, which is slightly different, we just drop the lanyard slightly. In this instance, we would fall the full length of the lanyard, so 1.75 meters. We now generate 1,850 kilograms of force. So the moment that fall stops, that's what's being generated, whether it's on the anchor, on the human. You can imagine the anchor probably going to break, the human probably going to break. We really need to consider where are we connecting to. And the final one, which is worst case scenario, 4-factor 2, that is where we now fall from here, the distance of my lanyard, so potentially 1.75 meters, plus then we fall another 1.75 meters for when I go below the anchor point. So in total, I fall about 3.5 meters. At the point that this device will stop my load from moving, I'm weighing about 3,600 kilograms. I'm moving 3,600 kilograms of force. I don't think there's an anchor in South Africa that's certified for that. So we need to be aware that these are the forces that we're playing with when we are dealing with fall arrest. I get that we use shock absorbers and that removes the forces, but the force still needs to move somewhere. And when that kind of force is being played with, realistically, it can move to the anchor point, it can move to the shock absorber and the person, and it can create other problems like fall clearance and distance that you're falling. Now, if we go to the takeaway of this, we just understand that connecting in these different orientations creates a significant change. From above my head, just over 1,000 kilograms, to at my feet, more than 3,500. So that's more than 3 times the forces. We need to be thinking about that when we are selecting where we put our anchor points. To make it a bit more practical, if we had to imagine this was a 10-meter lifeline that I was connecting to, so this one at 4-factor 1, and this one at 4-factor 2, keeping in mind the forces. 4-factor 1, we had that example. The first picture I showed was more or less at hip height, which means I would be connected at this point. And then we need to consider it's even more than 1,800 because it's on a cable. So it will generate, and it's quite tight, it will generate more force. But would this eye withstand a pulling force of 1,800 kilograms? Would this hook that is not even closed withstand a force of 1,800 kilograms? Would this turnbuckle withstand it? Would these clamps hold the cable in place and not let the cable pull out? Now, these are the things that we need to be considering if we're working in form factor 1 and making sure that we understand that is the risk. Because this not being a certified system, the probability is the hook will break, the turnbuckle and the cable will fight each other in that fall, and something will give in, something will break. And ultimately, the human will break because they will hit the ground, which is not okay because that's not the person that decided to use that system. They were just told to use it. The second consideration is the same thing. If we now consider form factor 2, because when I'm walking on a roof, I'm connecting at my foot level, we are considering 3,600 kilograms of force along that system at least. It could be bigger because of the length of cable and how tight the cable's been installed, which you can see this is really tight. Ultimately, realistically, if somebody falls on this and it applies 3,600 kilograms in that sideways direction, you best believe this is pulling off. Person's hitting the ground, and this is going to hit them on the head afterwards. So that's in terms of the anchor location. So where are we connecting? For factor 0, 1, or 2. The next consideration is the orientation of the anchor. If we're just creating a fixed point, I've just used 2 examples here, but there should be guidance from the OEM. In the first instance, if we load this anchor point toward this arrow or away in that direction, we can see this anchor point is not designed for that kind of loading. So that means if somebody's working on this side or that side of this anchor, if it fails, all the OEM are going to say is, well, you installed it wrong. Sorry, it's not certified for that kind of direction. And this is a critical thing that gets, I don't think most people even know they can ask for that. But it's critical because we can see that out of 2, 4, 6 orientations we can install this anchor, 2 of them could be life-threatening. Because where there's a sad face, it probably means it's going to fail. And that person is, once again, they didn't select which anchor to use, but they might very well hit the ground. Same goes for the next one. In 3 different orientations, we can't install this one. If we do, and if somebody connects to it and there's a plate that says this has been certified and there's a certificate that says we promise this is safe for use, and it is in this orientation, there's a high probability that person is hitting the ground. So our takeaway needs to be, with such large forces, the direction of the anchor must be correct. We can't just wing it and hope it's right. Okay, second last principle. So what we also need to think about is when we're talking about full clearance and the potential swing fall, full clearance is quite simple if it's a static anchor point. So if it's a static anchor point means if it's a type A anchor point in particular, and there's no chance that it's going to move once somebody's fallen on it. In the event of that fall, if you're using a 2-meter lanyard, you'll fall the distance of the lanyard. You could fall a maximum double that length because of the shock absorber to remove the forces. Those, what we spoke about, you had a fall factor 2, 3,400 kilograms of force. I need to remove the forces on my body below 600. The shock absorber will deploy and do that job. But that requires distance. So there, then from where the anchor is connected to the person's feet is quite possibly another 1.5 meters, if not 1.8 more, and a bit of grace by creating 1 meter distance safety factor. You would then, is the signal right? Gareth?
Hi, Dylan. It was lagging a little bit, but you are good to go now.
No, sorry about that.
No worries.
Okay, so in this instance, fixed anchor point, you're probably assuming you need 6.5 meters clearance to safely make sure you don't hit something below you. Now, this is a very simplified version because on site, there's quite often obstructions that are there. There's pipes, there's rubble, there's scaffolding sometimes. There's lots of different elements that might end up being a barrier that might obstruct the person falling quicker or earlier than the 6.5. We do also then need to consider if this is just a static point. If I run a 20-meter lifeline across here, temporary lifeline with webbing, a 20-meter webbing lifeline can create an extra 4.5 meters of sag if somebody falls on it in this instance. That means we're looking at 11 meters of fall clearance to make sure that this person does not get hurt. So there's quite a few considerations that we need to, and one of them is the anchor point static or flexible? If it's flexible, if it's webbing, we need to assume that the fall clearance will be more than what the lanyard tells you it will be, because that's just the lanyard, it's not the anchor point. The anchor location, this instance is worst case scenario. If we were connected above our head, this would be far less. But because we're not, we need to assume worst case scenario, and that's how we would work it out. We also need to assume what is the connecting. So we spoke about the ABCs. So the anchor point is fixed. The B is the body harness, but the connector can also reduce this distance because with a retractable lifeline, for instance, it operates like a seatbelt. The moment you start falling, it arrests your fall. You haven't built enough force to deploy the shock absorber as far as this would. So it's far safer, less likelihood that the person will knock themselves unconscious in general, but obviously there's a cost that comes with that. And then the consideration of what might be obstructing the fall. And that we need to, because no site is the same. No fall arrest situation is the same. We need to be considering that because that can be changing and that could highly affect the person that has fallen. We then got another principle, which is swing fall. So when you are not connected directly below your anchor point, you can see this person is more than 15 degrees away from the anchor. What will happen is the moment you fall, your weight will try stop under the anchor and you will end up swinging. In this instance, all that's happened is the person's fallen quite a bit lower because obviously if it catches him, he goes lower. So we need to incorporate that in our thinking from a fall clearance point of view. But more importantly, we need to consider it from is there a potential to strike something? Is there a potential to swing into something which will cause injury itself? So when we talk about the fall clearance and the swing fall, we must understand that the fall arrest is not only about stopping the fall, it is about stopping the fall before the worker hits something. And then we've got the final consideration. So once again, I've tried to condense the information and keep it as simple as possible. There's a few points that we weren't able to get into properly. One of them is training and competence. Something we must realize is the user versus the installer versus the person certifying the system. Those are different levels of competence. And if we think we're just going to send somebody on a one-day course and they're going to come out heroes understanding everything to do with fall protection, we've got people in our business that only focus on fall protection because of that. It's a constantly learning, it's a constantly understanding topic. I actually feel sorry for safety owners because of that, because I think that is the same for everything, for safety boots, for helmets, for gloves. Now you've got fall protection, confined space. It's very technical information. And we need to understand the training and competence that is connected to what they are doing on site. The second one, which I've pushed this point a lot today for a very specific reason, that we don't know what the inspections are supposed to look like. We get a piece of paper that says this thing is certified to this standard, or we get a piece of paper from the installer saying, I promise that I've pull tested it, or I promise that we don't have proof. When it comes to inspections, especially for anchor points and lifelines, you need to get the proof. Because if that thing fails, you're the one that will be accountable, and that unfortunately is not going to be a good situation. There are ways of getting the proof. You need to force for it. So just in closing, I'll get our marketing team to put this into a little 10-step toolbox talk. But this is probably a decent guideline to follow when you are considering anchor points on your site. So step one is let's define the task. Let's understand what the work is that is being done. How often is it being done? And by who? Once again, is it a technical work it out person, or is it somebody that's just unfortunately having to perform a job at heights today? The second one is let's assess the fall risk. So where can the person fall? How far will they fall? And can they fall onto something? We then need to apply the hierarchy of control. Can we ultimately eliminate it? Is there a way that understanding these 2 points, can we eliminate the need for fall arrest? No. Is there, starting with, can we eliminate the need to actually get to height? Can we then engineer it away? Can we create a restraint system that doesn't allow the person to be exposed to a fall? Or worst case scenario, fall arrest. We then need to define the system's purpose. So we need to be very clear. We can't just put an anchor point there and say, use it. How are they using it? Are they using it in fall arrest? Are they using it in fall restraint? Is there a specific connector they need to use? We must be clear on what's the expectation of using it as a system, not just an anchor point. We then need to also make sure we're assessing the structure. Is the structure in good condition? Is it going to arrest the fall and stay standing? Or is it going to arrest the fall but end up falling on the person? That's not going to help either. We then can start considering what kind of anchor. So right now, if it's an EN 795, sorry, it's not class, it's type A, B, C, D, or E. And then once we've considered that, is it temporary or mobile? Must it be in one place, or must it allow the user to move around to do their job? These factors will very much decide the productivity and the actual execution on the job and the use of safety. Because again, if my job is to do a little weld on a little chimney, and my system that I've been given doesn't reach there, and the weld's going to take me 2 minutes, I'm probably going to disconnect quickly. And then I'm going to become one of those statistics. Then we need to check the equipment compatibility. So is the anchor selected? Is it correct from the number of users? The lanyards and the SRLs, do we need to consider, are they using a retractable because of whatever reason? Is there other factors like leading edges and sharp edges? Unfortunately, that's a topic for itself. We'll get into that in another webinar, but that is also a critical one. Step 8, we need to then calculate the actual practical risk. So what is the fall clearance? What is the swing fall potential? Is it interfering with the job being carried out? Is it going to be used? Are we going to use the safety equipment? Step 9 is we confirm the competence. So we make sure that the user is competent how they should be, the installer, the inspector, the rescuer, everybody that touches this job needs to be adequately competent. And then the final one is we need to make sure that once all of that's been done, we keep everything from an information point. We document and inspect. It must be traceable, must be inspected, must be maintained, and ultimately you must have proof. Not a promise that we've installed it or inspected it properly, proof. If there's one takeaway, for us, it's the anchor point selection is not just a product decision. It is making sure that the whole safety system will work as it's intended. I hope this presentation was valuable. I hope it added value. If it helps save even one person, we've done our job. If there is any questions, feel free to shoot them through to us. We are quite active on We've got newsletters and LinkedIn and stuff like that. We're pretty active there trying to increase education and create good discussions to keep people safe.
Dylan, thank you very much for a very, very informative webinar. Just based on the chat box and all the compliments we received, it's evident that this was an excellent presentation. We really appreciate it. And also thank you to the questions that was posted. We've removed obviously the unrelated questions. Dylan, we still have more than 500 people in attendance. Are you happy that we go through some of those questions and you can answer them live? And then it will also then be obviously part of the recording, which people can go back later and watch. Are you happy for that? Great. So I'm just going to rush through them. I do believe that some of them was answered during the presentation. So very shortly, you can just say, yes, that's correct, or no, or we can't do a presentation on just about every question. But very briefly, Tapelo asked, do we know if the SABS technical has the knowledge and expertise, and are they amending the SANS 50795 to adopt the EN 795?
2012, yeah. Yeah, there's a very strong conversation happening now, but I mean, with SABS, it's quite tricky. I mean, they were supposed to kick off their SABS committee meetings and still waiting for the invite. So don't know when that will happen, but hopefully that becomes a very important discussion, and I think it will.
Okay, thanks. Then from Nukulonga, morning, thank you. And the question is basically, looks like he's with Eskom and he's conducting safety training, and he's asking about the anchor points required the moment you leave Earth to access it. While the procedure says immediately you leave Earth, you are on heights. What needs to be done to ensure they hook on anchor points safe? I'm not sure if you gather the question.
100%, and it's such a good question. I agree. I mean, ultimately, our goal is the moment somebody leaves the ground, they are safely connected. This presentation shows a number of different considerations to creating anchor points. It's a lot bigger of a task than that, though. To make it practical is difficult, but it will be possible. You need to be working with the right people, though.
Right, thank you. Lungelo again, what kind of anchor point is recommended for working at heights 2.5 meters or higher? I'm not sure why he's asking for that, but please note that there is no structure in place. The people are working on dry containers, spray painting and welding.
Okay. You do get some really cool, innovative products. So on a container, for instance, you get a container anchor point. You could use something like that. The problem, though, and what's quite important to mention on that 2.5 meters is with a container anchor, you're probably going to build a temporary lifeline across it. When that happens, you're using webbing, and that webbing can create a deflection or a sag. So there's a lot to contemplate on that, but it's possible, definitely.
Great. Thank you. Innocent asked, we often see riggers used to install lifelines and anchor points on construction sites. The question is, are they experts in this, and who should approve it before it's used on site? It's always difficult to have the OEMs to check and certify that it's been done properly.
Yeah, spot on. So look, you can't say that an LMI is not a work at height specialist. Just like you might not be able to say a work at height specialist is not an LMI. Those are two skills you can learn. But ultimately, at the end of the day, if you are not certain, you ask for the proof that the OEM has said you are competent to install that. That gives you the backup that they've got. And they should have a proper certificate from the OEM. And if you don't trust them, go to the OEM and ask them.
All right. Great. Okay, the next question regarding the proof load stroke pull testing for anchorage points, what type of documentation evidence would be considered acceptable to demonstrate compliance?
This is so tricky and really awesome question. The problem is the reality of us being able to do a proof is you would probably need to use the device connected to the anchor, pull it. Then you would need to film that for 3 minutes at least, depending on what the OEM calls for. Now, if you think about a site that might have 20 sites, you're now asking for 3 minutes times 20 videos as proof. It starts becoming a bit crazy. It's really not practical. There are alternatives. So what we will do is we'll share with anyone that's interested. There's a really neat new product that actually it monitors in real time. You can't change that. And that certificate tells you how many kilonewtons it held for the period. That then is, because then you know you can't bypass it, you can't forge it.
Oh, okay. Great. Thank you. Manuel asked, during the design of a property dwellings, is the design engineer certification sufficient to allow for any installer to install the design system? Or must the installer be rather certified by the OEM and provide a certificate of test?
Yeah, so in Work It Out, we obviously have engineered, you've got self-identified anchor points. You've then also got certified. If you are using a certified, it doesn't matter what background, you need to have competence from the OEM, proof from the OEM that you're competent.
Great, thank you. Tumelo asks, hi, can a crane be used as an anchor point when offloading equipment from a truck, for example, a compressor?
Ideally not. I mean, so like I just said now, you can have an engineered anchor point or so a self-identified anchor point or a certified. That could be considered a self-identified anchor point because if you think about it, what I mentioned earlier, it can hold a 1.5 ton bakkie. The problem though is there are other components to that equipment, meaning if somebody accidentally hits a button and it pulls the person up, you're in deep trouble. So ideally, yeah, no, don't cross the two.
Thanks for that, Dylan. Tapelo says, last question from me. I think he's asked about 3 or 4. The choice of vendor we use for anchor points must be certified / accredited by OEM, ? Which in most cases is difficult unless you have internal expertise, which with that as well is very rare.
Yeah. I think that's a perfect statement. It's very
It's a good statement.
There are companies like Protekta. I mean, that's our goal. Our goal is to educate. Where we can help, we help. Where we can give information, we give information. We just want people to be safe.
Great. Thanks, Dylan, for that. Jenny says, as the person that draws up the floor plan, etc., should we do that inspection on this type of installation into concrete, or should it be outsourced?
So this is such an awesome point. So we've been talking a lot in everything that Protekta is talking about right now is making Work It Out practical. The first thing is the fall protection plan. That for me, we get that so wrong. If we do this properly, the fall protection plan should indicate what the anchor should look like, what the connector should look like, what all of those are. You're not responsible to put that in, but you are responsible to know that it will work safely in the event of a fall, and then instruct what it is you need. So using it as a guide, phenomenal, but I don't think it means you need to install it yourself. There are people.
Great. Thanks for that. Stefan asked, is there a calculation to determine the amount of kilonewtons or the weight that the system has to be tested against? I think you covered that. For example, single user weight, 100 kilogram. I think that was covered quite well. I don't know if you want to add to that. Yeah, we saw that.
The standards have their certification. I just made it practical as to what it can look like. But usually you're working anywhere from 12 kilonewtons to 22 kilonewtons.
Right. Augustinus, hi, just need to know the pull test device, it should not be calibrated, ?
It very much should be calibrated, good point. So annually, that should be calibrated and made sure that the readings are correct.
Right. Thank you. Susan asked, in case where people work around 8 to 12 meter deep trenches at an open field, remote, without any structures close by, can a TL be for instance, be used as an anchor point to attach workers, similar
Yeah,
to the
get
crane, I
same
presume?
thing. Yeah, same as the crane. There are devices that you can put into the ground. So there's anchor points like that. But
Right. Okay, thank you. Next question. Good day, Dylan. SAIOSH. After an installation, does the manufacturer give you a manual? Are we supposed to request for it?
yeah, there should be a user manual for any of the equipment you use.
Right.
Often it might not come with the equipment, but you should push for it, because for you to use that equipment safely, you should follow the manual.
Right. There's the second last question from Stefan. So should we calculate out the arc of the swing when determining the anchor point to allow us to use them swinging, prevent them from avoid from swinging into something?
Yeah.
Can imagine.
Ideally, what you want is you don't want the anchor point to be more than 15 degrees away from you. So if you've got a fixed anchor point and it's probably 3 meters behind me, when I fall, I'm going to swing. You want it to follow you and be with you all the time above your head.
Right. 100%. Thank you. And then the last question from Jenny. Isn't it then the installer's duty to do the inspections on the type of metal and concrete that bolts for the lifelines get to install into it?
100%. But I mean, so that first picture I shared with you, right?
Right.
If I can use that as an example, that was the installer's responsibility to make sure they're installing into the right wall, into the right system. That installer is no longer doing business.
Right.
Who's left with the problem? And unfortunately, we need to consider it that at the end of the day, it's going to be the safety person who is responsible. So rather get your checks in place.
Right. Understand. Dylan, thank you very much. Much appreciated. And just a quick piece of information to our attendees. It was put into the chat. This is one of 6 webinar presentations that's coming from Protekta. You specifically picked this as the first one, but possibly one of the critical ones. So to our members and to our attendees today, please have a look out for when we plan and to schedule the other 5. And you are in for a treat, if I can put it that way, with great information. And thank you very much once again, Dylan, for taking the time out and to enter into this partnership with SAIOSH. We've got lots of members, and I just knew when this webinar series was going to be announced that we're going to have a great response. Much appreciated. We're looking forward to see you again. I just want to make 1 or 2 final comments before we close off, but thank you very much. Much appreciated.
Thanks, Niels. We appreciate everything from SAIOSH, and we look forward to it.
Thank you. Just in closing, just a reminder to our members that a copy of this presentation will be emailed to you, and that the recording of this webinar will be on our YouTube channel, and members will also get a link to it. Thank you very much for joining. Just a quick reminder that our annual flagship event, the SAIOSH Annual OHS Conference, is taking place on 31 July 2026 in Cape Town. We are just about fully subscribed, so if you're interested in joining the flagship event of SAIOSH, please go to our website, www.saiosh.co.za. And if you're not a member yet, please consider to become registered professionally with SAIOSH, the only SAQA recognized voluntary regulatory professional body in South Africa. We appreciate your attendance. Until the next time, cheers everybody. Bye.